Time for some exponential equations. Okay, these all basically work the same. Let me pull up the main formula that we're going to use to solve questions 1 through 7. And here it is right here. So if you have two bases that are the same and there's an equal sign between them, then your exponents have to equal each other. Say that again. The bases are the same, there's an equal sign between them, the exponents have to equal each other. Might as well show you the rest of this resource sheet. This is powers of 2, 3, 4, 5, 6, all the way through. Okay? You should know these, right? Especially the powers of 2, powers of 3, powers of 5, 6, 7. You'll notice there's no powers of 4 or 8 or 16 because they're already existing powers of 2. But you should know these. This is a resource. I'm just going to put this right next to the worksheet. Should make your calculations a little bit easier. So let's get back to the problems. First problem, easy, right? Because 16 is 2 to the 4th. So the bases are the same. Therefore, the exponents have to be equal. So x equals 4 on number 1. Number 2, you try to turn the bigger number into the smaller number with an exponent. Okay, if you can. So 3 squared is 9. So that we're going to change the 9 to 3 squared. So now we have the bases are the same. Therefore, the exponents have to be equal. So x minus 1 equals 2 and x equals 3 again for number 2. Number 3, 125, I'm hoping you remember, is 5 cubed. So the bases are the same. You drop the bases and 2x minus 1 equals 3. Therefore, x equals 2. Here comes the harder one, number 4. 8 is 2 cubed, right? 8 is 2 cubed. 128 is 2 to the 7th. So these are both bases of 2 somehow. So we're going to change this mess into 2 cubed raised to the x equals 1 over 2 to the 7th. Now the power of exponents comes in, the rules of exponents. When you raise one exponent by another, you multiply them. So 2 cubed raised to the x is 2 to the 3x. And what I did with 1 over 2 to the 7th, I took that 2 to the 7th and I moved it from the denominator to the numerator. Therefore, I had to change the sign of the exponent. Say that again. When you move a value that has an exponent, either up from the denominator to the numerator or backwards from the numerator to the denominator, you have to change its sign. That's all you have to do. So now the bases are the same. They're both 2, and we have 3x equals negative 7. Therefore, x has to equal negative 7/3. Number 5, positive 3 to the x equals negative 3. This is undefined. We do not have an exponent that changes the signs of a base. In other words, a positive number will never change to a negative number with an exponent. Now, a negative base will, right? A negative base will turn positive anytime the exponent is even, but not a positive will never change into a negative, with one exception. Okay, there is one super duper calculus based exponent that will change a positive number into the negative number, and I keep forgetting what it is, but I'm pretty sure it's very strange. It's like negative pi to the I, something like that. I used to know what it was, but I don't. But at this level, just remember, positive numbers do not change signs due to exponents. Okay, so that's undefined. Number 6, you'll notice that you have a factor out here, 5, that isn't really part of this term that has the exponent in it. So, right, so what we're going to do is we're going to divide both sides by 5 first. That allows us to drop that 5, and that comes out to be this. So we're going to turn 81 into 3 to the 4th. Sorry about that. And so the bases are the same. So we have 2x plus 2 equals 4. So therefore, x has to equal 1. Number 7. So 4 to the x equals 1 over 64. 4 and 64 are both powers of 2. But I know that 64 is 4 cubed, right? 4 times 4 is 16 times 4 is 64. So I'm just going to leave it to the base of 4. So 64 is 4 cubed. 1 over 4 cubed is the same as 4 to the negative 3, right? I moved it from the denominator to the numerator. Therefore, I had to change its sign. The bases are the same. x has to equal -3. Okay, this one, number 8, much more difficult problem. So this number E is Euler's number. There's a video in this section somewhere. I strongly suggest you watch it. Euler was quite a mathematician. So e raised to the 2x minus 3 e to the x minus 10 equals 0. This is when we're going to substitute. We're going to let e to the x equal some other variable. We're just going to call it u. So we're going to change the original equation into something with u, and a u is going to equal e to the x. So most people get stuck on this first term. E to the 2x is the same as e to the x, parentheses, and that whole thing squared, right? Because when you raise e to the x by the power 2, you multiply the 2 by x and you get to e to the 2x. So e to the 2x becomes u squared, minus 3e to the x just becomes 3u, and then just minus 10. And this factors out very nicely into the product of two binomials, u minus 5 times u plus 2 equals 0. Therefore, u has to equal to either a positive 5 or a negative 2. So that's the first half of the problem. Now we have to resubstitute back in e to the x for all the u's. So instead of u equal 5, we got e to the x equals 5. So this is a little bit ahead of time, but I'm trying to segue into when to take a logarithm. And I'm going to say this about 1,000,000 times. When the variable is the exponent, or the exponent is the variable, that's when you take the logarithm of both sides. It's called the power rule. But so when we take the natural log of e to the x, that equals the natural log of 5. You got to take the natural log of both sides. So the power rule is if you take a logarithm that has an exponent in it, the exponent comes out as a factor. And natural log of e is 1. So we got x equals the natural log of 5. That is a real number. And I will show you how to do that. So you just take 5 and you hit natural log ln. Boom. So it's like 1.61. That's what x equals the first time. So e to the x equals -2 for the second half of this problem. I'm sorry, for the second value for u. E is a positive number, right? It's 2.72, and it changes into a negative number? No way. X's are, again, our exponents will not change a positive value into a negative value. So this second one is undefined. There's only one answer to number 8, and that's x equals the natural log of 5. So let's jump on down to number 9. So this is a mess, right? If I'm gonna add 15 to both sides. So I have the term with the x in it on one side of the equal sign, everything else on the other. But now 16 is not a power of 7. Yeah. So here's the logarithm rule again. We're going to take a logarithm of both sides. This one's going to be a common log because it doesn't have an e in it. You take a natural log whenever there's an e in anything. But with this one, we're going to take a common log, and we just take the logarithm of both sides. So the logarithm of 7 to the 3x equals the log of 16. We're going to use that power rule. Any exponent that's being taken a logarithm of becomes a factor on the outside. Okay? So now we got 3x times the log of 7 equals the log of 16. Yeah, log of 16. And we're going to divide both sides by everything that's not x. So first I'm going to divide by log 7 of both sides. Did that right there. Now I'm going to divide that whole chimichanga here by 3. So that gives us x equals the log of 16 divided by 3 times the log of 7. Yuck. What a mess. And they're the real numbers. And there it is right there. Boom, boom, boom. So I'm going to double check this answer, right? 7 to the 3x. And I'm just going to use 0.48. Let me pull up this guy. Clear you out here. Boom. So 7 raised to parentheses 3 times 0.47. I'm just going to call it 7, I guess. Close parentheses. And that's going to be 7 raised to that power. and I'm on a minus 15. Minus 15. And that should be close to 1. It's relatively close, right? Because we really, really rounded down here. So that looks like the right answer to me. But again, the reason I give you these logarithm problems is because that's where we're going. You got to know logarithms, and we're going to go up and down and around the town with the logarithms. But that is it for the homework assignment, the worksheets. MGZ out.